Hi, my name is Martin Lohr. I'm the CEO and co-founder of Sixonia Tech, and in this short video I will present you shortly how versatile our E-Graphene materials are and how they can be used in different applications. So our E-Graphenes basically are electrochemically exfoliated graphenes that are rather large in flake size, so typically in the micron range, and also a few layer nature. So typically they are 10 layers or less thick, and in dispersion usually even just up to 5 layers. The functional groups that we are introducing in our electrochemical process can be tailored to really fit with the application you have in mind. So we can make the graphene dispersible in various solvents or compatible with different matrix systems. And this is really one of the advantages that we have, because we can do this without actually losing the conductivity of the material. So we can keep a material with large lateral sizes, high conductivity, that's also processable easily, and that makes it very interesting for a variety of applications. Right now we are scaling up this process to a scale of 1 kilogram per day, which we will finish this year. And if we talk in a long-term perspective, we are also positive that we can provide these materials for much less than 100 euros per kilogram in a later stage at the level of industrial production. So if you look at our graphenes, there's really like one thing that distinguishes it from other materials, and this is what I said already, is that they are high quality materials which are very processable. So what you're seeing here is the SEM image of some graphene flakes that are actually dispersible in water without the use of any surfactants. But still, if you look at the Raman, for example, you can see that in the center of the flake you have a very, very low level of defects, and the conductivity of these materials is really very high. So up to 60,000 Siemens per meters is something that you do not easily find in other graphene materials. And with varying functional groups, we can also easily disperse these kinds of materials in other solvents like ethanol water mixtures, ethylene glycol, DMF, NMP, DMSO. So these kind of materials or solvents that are typically polar solvents are all working very nicely with this kind of material. But obviously also if we change the functional groups, also different solvents are accessible. So it really depends on the application that you are interested in. So to give you some example on how easily these graphenes can be applied. So this is just like an example, for example, to spray coat them onto various substrates, which can easily achieve resistivities down to a few hundred ohms or tens of ohms, or even like produce freestanding films just by simple vacuum filtration, where the resistivity quickly goes down to below 10 ohms per square, which is, I think, quite impressive for graphene-like material. The applications that you could use these for are, for example, for heating elements, for ESD protection or EMI shielding, even antennas can be possible. And obviously, if you spray coat graphene on a non-conductive material like a polymer, you can create a conductive surface on a non-conductive material and use that, for example, for just to use a galvanic metallization process, for example. That is, I think, quite a promising direction as well. Another application basically is the functionalization of textiles. So if we're talking about smart textiles, e-textiles, so introducing heating functionalities or sanding functionalities, and this is something that we have been doing in collaboration with our partners from Graphen from Sweden, who are also presenting here, and I think they have achieved quite some impressive results, and I would really recommend you to visit their booth and have a look. The third application basically is the basically the coating of very, very complicated surfaces. So this is like an example where we have a ceramic template, which is basically a zinc oxide, and eventually the graphene dispersion that we are using can be infiltrated in such kind of molds that can be created from this kind of ceramic particles. And you can see easily in this nice video here that the dispersion does not filter or something. There's no kind of a grading effect on the surface. So the well dispersed material inside here, this aqueous dispersion in that case, is really coating uniformly this rather intricate template. So you can see here in these pictures that if you etch this template away, you keep this nice structure completely intact, and the graphene is really conforming very nicely to the surface of these particles. And what these materials actually can be used for is air filter materials, which are currently developing in collaboration with different partners inside the Graphene flagship in the Spearhead project Aerograph. So if you have a material that has such an intrinsic structure, it's basically very similar to a HEPA filter, but it's made entirely out of graphene, you have a filter that's conductive. So if you have a conductive filter, you can just apply electricity to heat it up, and in this case this is really possible within milliseconds, and we can use that to either regenerate the filter or kill any viruses and bacteria that have been filtered in this material, or also to just simply monitor the filter status. So if the filter is highly loaded or it's fine, we don't have to regenerate it right now, you can easily measure that by the response to an electric signal. So this is also very exciting. Another example that is very typical for graphene generally is the use of it as an additive in thermosets. So if in case here we have an epoxy matrix, the idea was to use it as basically as an additive in electrically conductive adhesives. So in electrically conductive adhesives, you usually have a very, very high amount of silver, for example, because they're usually used where you cannot really solder. So they're used to replace soldering materials, for example, because the electronic components are not withstanding so much heat that you use for the soldering process. But the replacement for the solder obviously has to have a very high conductivity. And if you have a material like an epoxy resin with 90% silver, for example, you can imagine that the structural stability of such kind of a conductive adhesive is rather low. So the idea was basically to add graphene here to improve the structural performance, and this has been working very nicely. So with just adding 0.9 weight% of graphene in relation to the polymer weight, we could really improve the flexibility of these materials, decrease the brittleness, while still improving also the adhesion and mechanical integrity to different substrates. So I think that is also very promising. And yeah, basically the only important thing I think that is limiting us in somewhat is that we are not offering any kind of powder materials. So we are always working in dispersions, pastes, or other kind of liquid formulations. But still, this leaves a lot of room for opportunities. And if you're interested to find out how these materials can really be used to unlock the potential of graphene in your specific application, please reach out to me. I'm looking forward to talk to you.